Next up, we have one more example where a couple of events have some overlap going on. So, the problem says you are performing an experiment to determine how well plants grow under different light sources. Out of the 30 plants in the experiment, 12 receive visible light, 15 receive ultraviolet light, and 6 receive both visible and ultraviolet light. What is the probability that a plant in the experiment receives either visible light or ultraviolet light? Well, the first thing you'll notice is that I've added a Venn diagram to this problem. The Venn diagram, I've got a couple of different events, and you notice that they overlap in the middle. So what I'm going to do is I'm first going to put down a couple of numbers that describe my situation in this diagram. First of all, I know that there's 30 plants total in the experiment, so I'll just put a 30 just on the outside of the rectangle. Now I'm going to label my two different options. So I can either receive visible light or ultraviolet light. So those are two different kinds of light that these plants are receiving. So then I think I'm going to fill in these circles with the different numbers that I need. So first of all, with the Venn diagram, I like to start with the overlapping portion. I want to think about how many receive both of these two things at the same time. Well, I notice 6 receive both visible and ultraviolet light within the problem. So I'm going to go ahead and put 6 in the middle of the Venn diagram. This is representing the overlapping region. Then I'll fill, let's see, the visible light part. I notice that 12 of the plants receive visible light. But rather than putting a 12 here in the circle, I need to think about the fact that I already have 6 of those plants accounted for in the overlapping region. So if 6 receive both, that means there must be 6 that receive just visible light, because 6 plus this 6 would have to be the 12 that I'm given. Now for the ultraviolet light portion, 15 receive ultraviolet light. 6 have already been accounted for in the overlap, which means there's room for 9 plants that receive only ultraviolet light. Now, if we added up those numbers, you would notice that we've got 15 plus 6 is 21. If I really wanted to label the rest of the diagram, I suppose I could put another 9 outside of those two circles, representing plants that don't receive either of these kinds of light. And I knew it was 9 because if there's 21 plants here, and there's 30 plants total, there must be 9 that aren't receiving these two kinds of light. Now, I was asked to find the probability that a plant in the experiment receives either visible light or ultraviolet light. So again, I'm going to label a couple of events. Event A is the plant receiving visible light. Event B is ultraviolet light. So as I look for the probability of event A or B occurring, I already know from my Venn diagram that there's some overlap, correct? So that means what I'm going to do to find this probability of this compound event is take the probability of one plus the probability of the other minus the probability of the overlap. We can go ahead and fill in some numbers in those particular situations now. So the probability of a plant receiving, the probability of event A, a plant receiving visible light. Well, let's see, visible light, I've got 12 out of 30. 12 out of 30 receive visible light. So I'll put 12 out of 30. It's event A. The probability of event B, which is my plant receiving ultraviolet light, well, I notice that there's 15 out of 30 that receive the ultraviolet light. I'm going to add those two together. Now, because this is an overlapping compound event, I then have to, at the end, subtract the overlap. The overlap was the 6 that received both visible and ultraviolet light out of the 30. So we subtract 6 out of 30. 12 plus 15 is 27. Minus 6 is going to be 21. So in the end, when I put these all together, I have 21 out of 30. 21 out of 30, we could reduce that, I suppose, to 7 out of 10, or if you really like decimals, that would be 0.7.